Good morning. My name is Andrzej HANUSIK. I work at the University of Economics in Katowice in Department of Transport. Today I will discuss the results of a new delimitation model that can be applied in the GZM Metropolis. This article serves as the extension of previously conducted research, which resulted in the publication of the scientific monograph. In this research, I focus on attempting to determine how the adapted area delimitation model would influence the fitting of the econometric models. As a research field, I selected the largest urban area in Poland, namely the GZM Metropolis. For the first stage of the research, I utilized the delimitation model currently functioning within the Metropolis, which divides entities into core cities and other cities and municipalities associated within the metropolis, but characterized by a lower level of economic development. The results of a model fitting for the three delimitations group are visible in the presentation. Group 1 consists of all cities in the metropolis, Group 2 includes the core cities, and Group 3 comprises the remaining cities and municipalities associated with the metropolis. The multiple regression model was only well fitted in one case. This is core cities of the metropolis. In the case of analyzing the entire area, the model was characterized by a very large standard error and low R-square and R-square adjustment coefficient. For the suburban cities, the model met all the fitting conditions except for the height coefficient of error. This result suggests that the current delimitation model is not optimal. Therefore, it is necessary to search for a better model that will ensure a higher level of economic model fitting. This is precisely the goal of this article. The data used in the analysis came from sources including the Central Statistical Office of Poland, the GZM Transport Plan, and the Metropolitan Railway Concept. The same set of indicators was previously used to assess the fit of multiple regression model. In this study, these indicators form the basis for a taxonomic analysis, the result of which will be establish a new delimitation model to be used in the future for reassessing the fit of the multiple regression model in the metropolis. The variables were selected to best correspond to the flows that occur daily within the GZM metropolis. The dependent variable chosen was the modal split for the most common category of obligatorily travel, namely the home-work-home trip. The explanatory variables were identified during the focus group studies conducted as the part of the research team's work. It should be noted that these variables pertain to past years, despite the availability of more recent data for some of them. This decision was made to ensure continuity within the research conducted in the previous stage of the analysis. At this stage, I would like to discuss the methodology for creating the delimitation model. First, the coefficient of variation was calculated for each variable to exclude those with low variability. The next step of the analysis involved determining the correlation between variables. A correlation matrix was created and subsequently inverted. The critical value of the diagonal element was also calculated. Variable selection using the inverted correlation matrix is an iterative procedure. All variables with diagonal values exceeding the critical threshold should be excluded from the further analysis. In the first iteration, the variable with the highest value is removed. A new matrix is then calculated, excluding the identified variables. This procedure is repeated until all variables have diagonal values below the established critical threshold. An assessment was also conducted to determine whether spatial correlation exists, utilizing global Morans 1. Additionally, the mean absolute value of the global means Morans I indicator will be calculated. If strong spatial autocorrelation is detected, spatial regression models should be employed in future studies. The next stage of analysis involving normalization of the variables. The classical standardization method was used. To conduct the new delimitation, agglomerative methods will be employed, especially word method. This approach combines clusters in such a way as to minimize the sum of square deviations of all objects from the centroids of the clusters to the centroid of the new cluster. Here we can see a linkage dendrogram. This is a plot of linkage distance against the stage of linkage. The graph will indicate the first significant increase in linkage distance, which will facilitate the formation of groups of cities and municipalities. The division should be made after step 39. This situation arises from the occurrence of the greatest increase in the binding distance at this point. As the result, two groups were identified, each comprising cities and municipalities with similar characteristics. The analysis conducted indicates that, based on the provided data, Metropolis GZN should be delimited into two main clusters, as illustrated in the map. Additionally, the figure highlights the current implemented delimitation model in the Metropolis, with the core cities marked by the bold line. This division stands in opposition to the traditional accepted classification of Metropolis, which separates core cities from the other municipalities and towns. Both classifications share certain common features. For example, similar cities are grouped into the same clusters, yet there are significant exceptions. Firstly, Świętochłowice was not included in the group with the other core cities. A clear distinction is also observed between the central area and the southern and western regions. This might be attributed to the fact that transportation within the metropolis operates relatively smoothly along the east-west axis, while there are certain limitations along the north-south axis. A good example is the city of Tychy, which is classified as a part of the metropolis core city, but was placed in a separated cluster in the conducted analysis. This conclusion has been confirmed by traffic studies. It should also be noted that the differences between the obtained division and the currently implemented delimitation model in the metropolis may stem from the selection of diagnostic variables. In the analyzed case, only variables related to population flow were considered, while typically economic variables, such as those describing industrial development, income levels, etc., were not included. Incorporating variables of this type into the model would very likely yield results more similar to the currently functioning delimitation model. However, it is important to emphasize that while these variables are significant from an economic perspective, they have limited impact on the modal split. Moreover, even if such an influence represented, the traffic structure itself serves as a reflection of the region economic condition, thereby indirectly incorporating these aspects into the proposed model. So the distribution of workplace affects the daily travel patterns. This situation suggests that the proposed division can be effectively used for the transport policy purpose, but it might prove insufficient for other applications. This conclusion highlights the importance of selecting an appropriate delimitation model tailored to the specific objective. Using a single fixed delimitation model for all analysis will result in mismatched outcomes. The conducted analysis will serve as a basis for further in-depth research on the fitting of economic model, depending on the chosen model of delimitation. These results will then be compared with previously obtained outcomes, which will enable an attempt to develop a delimitation algorithm. And that's all. Thank you very much for your attention. If you have any question, please feel free to contact me at the provided email address. Thank you, have a nice day, and goodbye.